Hi, and welcome to the second episode of Troubleshooting Series for Azure Database for MySQL. And I'm sure you would have come across many issues when trying to connect to your database. However, today we will be covering some of those error messages and what issues you can get and what are the best practices to follow to avoid most of those issues. And we'll also cover some troubleshooting techniques, how we can narrow down the issues step by step to the right cause. To go over the topics, we'll first look at the network topology, public and private. The database server can be deployed into a public network or a private network, and how the communication flows. We'll take a look at that. Then we'll look at connection strings, what issues we can have with errors in connection strings and the client versions. And then we'll look at the firewall or network security group, which we use in virtual networks. And then comes the SSL encryption and what server parameters we should use for the right connection. And now when it comes to network topology, we know that network itself is a complex with so many layers. Now add network virtualization to that, which is by default used in most of our cloud technologies. It can get very complex. Now how we can break that down into smaller chunks to make it easier to troubleshoot and figure out the issues, we'll look at today. Now let's look at the network topology, basically how the communication flows. Now let's consider Azure Cloud, and where we have a firewall, since it is the public network here, and we have a Azure Database for MySQL deployed into the public network, where we are protected by that firewall, which by default blocks everything, and we need to allow what we want to connect to the database, right? So now let's look at the internet connectivity. Let's say you're connecting from a on-premise machine, or you're connecting from another machine from another cloud provider. It could be the application, or you're just connecting to do your DBA roles. Like the communication will flow through the DNS of your network to the internet, and then through the firewall, you'll reach the Azure Database for MySQL. Now, why you see DNS in so many places here is because this is what's responsible for resolving a name to IP. It's more like a phone book of the internet, and it is maintained at different levels because you know what's in your network, and so you maintain that at your level. Similarly, we maintain that at Azure and internet, there are servers, and your ISP will maintain at each level, so which helps us convert the name to the IP address. And we'll look at some of the troubleshooting tools such as NSLOOKUP to find out how we can easily figure out whether this is a problem with name resolution or something else. Now let's look at the private connectivity, how that works. Let's say our database is deployed to a virtual network in Azure. Now the only resources that can communicate to the database that reside only in that virtual network, like this Azure VM1 can connect to our database. However, if we have a resource in another virtual network, could be deployed in Azure VM or Azure App Service or Azure Kubernetes Service, it by default cannot communicate to anything on the Azure VNet 1. Now, the way to achieve that connectivity is by using VNet peering. So we can establish peering and link these networks, and then basically link the DNS so that the name resolution works. Because if we can't resolve the name, even having connectivity doesn't help us reach the right address. Now, how you can connect from an on-premise or a third-party cloud? The best solution there is using a virtual private network, the VPN, which is quite popular these days, which also gives you secure connectivity between networks. The connectivity is tunneled over the public network, so it is secure. And you also have something called as Express Route in Azure, which gives you a dedicated bandwidth through an ISP to have a very good connection. Right. Now, these are the two ways of connecting. Now, let's look at some of the best practices that you can follow to avoid most of these issues in the first place. So you spend less time troubleshooting and more time working on your databases. First thing is, make sure you always allow your IP address of your client in the Azure Database for MySQL firewall. And the tricky part here is that if you do a if config or IP config, you will see the IP address of your machine, but that may not necessarily be your public address. The way to find out a public address is you can do it through sites such as whatismyip.com. Azure portal itself shows you the address in the firewall page. You can use that to add as well, and just to make sure that it is correct and add it. This applies only to public connectivity. And next is the SSL encryption on the go, where we use the latest compliant TLS version. And what server parameter to use when you're connecting, what parameter to use with your connection string to get the right SSL connection, whether you should use your file certificate, or if you set the parameter to correctly, or if you don't even specify the parameter, does it default to a particular parameter? Understanding this helps you, make it simpler and easier to connect. Syntax can vary from version to version and platform to platform. Not that the syntax itself varies, but sometimes the platforms have their own issues in how they read the characters that you type in. Sometimes the space can be read in such a way that the subsequent parameters are not read at all, or some error in your previous parameter value that you're providing, let's say some special characters, can mess up with the entire connection string. So to be aware of these things and avoid them would help a lot here. Always try to use the latest stable client of the version. So if the server version is older, it is fine. The latest version should be able to connect to them. But however, the other way around is not ideal. It's not going to work. Now, when it comes to version compatibility, the server and client version, as much as possible, try to use the same version. Like if you're connecting to a 5.7 server from a 5.6 client, it's going to be problematic. And we may get errors, we may not get errors because they are never designed keeping in mind with each other. So we may have symptoms that are not possible to troubleshoot or hard to troubleshoot. So version is important there. And also there is a practice that people mix the client and server between MySQL and MariaDB. Let's try to avoid that, or if you are having issues, that's one quick check to try with the right version and see if that solves your problem, right? And network connectivity itself is not broken. Sometimes there could be network errors or some changes in the network that can lose your communication. It could be at DNS level also, which is the next topic, which is name resolution. So since we have DNS in every network, every phase, things can go wrong where we are not able to resolve the name to the IP or the right name to the right IP. And that can be problematic where we may not reach the right place for the connection and will be refused. So we'll look at how we can troubleshoot all these in some of these scenarios. So major scenarios we'll cover in today's demo is connection strings and syntax, and how certain characters can cause problems. Firewall and IP address and the port, like how you allow it through a firewall or NSG, and how to know your public IP address. And encryption, SSL, like whether to use a server parameter to specify SSL or not, or whether to use a certificate in what situation, what is the best approach. We'll learn that. Hey, let's start with scenario 1. Here we are looking at Azure Database for MySQL flexible server deployed in a public network. How you can see it is a public network by going to the networking section, and it's either public or private. So here we have created as a public network, and in the overview page you can see the server name. This is the fully qualified domain name of this server, which is what is resolved to the IP address when we connect. Now let's switch to our MySQL workbench, where we'll try to connect, and this will attempt a couple of times before it times out. And there we got the error. Connection attempt to this server name 3306 port is taken as default. Unable to connect to localhost. Now, if anybody reads this error message, it's not clear like what error message means and why it failed, right? So why localhost comes into picture is by default MySQL clients, when they try to connect to the remote address and they fail to connect after several attempts, it'll try to connect to the MySQL installed on your machine locally. And that last attempt is this error. For the previous attempt errors, we have not seen. That is why these errors can be so confusing, and the error doesn't mean the actual issue. The issue can be something else. Now let's see how we can fix this issue. Now let me quickly show you the connection here. So here I have the fully qualified server name and the port mentioned and the username as per portal, and we have SSL setting set as require. So let me just, for some reason, I'll just change it to no. Let's say I want to do that. Let's see. Whenever I make changes to the connection, needs to be tested before I can save it. Same error message, right? Unable to connect to localhost. This is one demonstration that you can have a same error message, but the reasons for the error could be different. We will uncover this shortly. So let me go back to the portal. Now, how do we figure out, right? So if I go to the firewall, so this is one of the best practice to check. Like currently there is no IP address that is allowed to connect to the database. Now this means no matter what other settings are, what other issues exist, you will still not be able to connect. And there is one setting which is allow public access from any Azure service to connect, which means any virtual machine or any resource within Azure can be allowed to connect from here. So you don't have to specifically mention that IP address, but anything from outside we'll need to add. So here Azure kind of finds out what is the IP address of your local client, and it will show you that here. There is a simpler way you can make sure is what is myip.com. So this is a site which can tell you your public IP address 167.222.38.95, and I can go back, but you can see the last octet in this IP address is probably detected wrong, maybe because of what calculations are used. So sometimes if you simply add this here and save it, it may not work. You may need to find out what is your actual public IP. This is same octets, but the last octet is 95. So you may need to add that. So here what I'll do for sake of simplicity, I will simply make it a range of IP from 31 to 95, and then I will save it. Okay, it's successfully done. So let's go back to our workbench and let's try to connect now. Now it's asking me for the password, which means we are reaching the server and we are getting back a response asking for authentication. This is one step ahead, which means we are gone past the first error, but then we'll see. We'll give our password and what happens next. Now I'm getting a different error message. This says connection using insecure transport are prohibited while required secure transport is on. What this means is like we are able to connect to the server. So our IP address is whitelisted in the firewall. We have got past our first barrier, but we hit the second barrier where our database server enforces SSL, but we are not using SSL. We can see that here. If I go to the server parameters and look for secure transport server parameter, so the required secure transport you can see is on, which means the client must use SSL, otherwise the connection will not be allowed. So I can either set this to off, which should allow me to connect, or to be more secure, I can change the server parameter in the database server. So we can do both as well. So I will show how to do. Just set it to off and save it. I'm not going to do that now. Let it be on. And let me come back to our connection here. And in the SSL, I'll set it to require, which will use SSL for the connection. And if I say test connection, it's asking me for the password. And the connection is successful. And the successful connection is made. Now I am able to save this connection. And if I click this, I will be able to successfully connect. we go. We have successfully connected. If I simply execute, I should be able to fetch the database names and run my queries from here. I'd like to show you something cool here in Azure. So when you go to any resource group, there is on the left hand side blade, you will see a resource visualizer, which can show you the different resources. You can actually move them around. So I've actually moved them according to how my earlier network architecture diagram was, so that you can relate to it. Now, you can also save this as a PNG picture. And if I save it, it's going to look something like this. All right, here is one that I saved earlier. So here is the Azure Database for MySQL that I've deployed in the public network, which is not on any VNet, which is directly connected to the internet. Here is the Azure Database for MySQL, which is connected to the private network, which is this VNet, the MyAppNet. And I have another VNet here, which is App VNet 2. Here is the private DNS zone for the database server. And I have a virtual machine here, my app VM1. And these are the associated resources. Like this is the virtual NIC card. This is the public IP of this VM, so that the VM can be connected from the internet. The NSG associated with the NIC, and this is the disk for this VM. So similarly, here I have a VM2 with the same resources in the VNet2. So now by default, we cannot communicate between VNet and VNet2 because there is no link that exists. There's no VNet peering or anything. So we'll look at the connectivity to the public one and the private one. Let's go to the resource from the resource group here. So if I go to the overview, and let me go to the public network first. My MySQL server deployed in the public network. So here you can see in the networking, it's public access. Here I have connected to the Azure CLI. And so if the connection is successful, it should connect immediately or within a couple of seconds. If it's taking time, which means that there may be a problem connecting, and it's going to retry a few times before it throws the error. Okay, so we got this error, can connect to the MySQL server. Let's see why that is. So if I do if config, so I can see the IP address is different here for this Azure CLI session. So in the meantime, I will also add the IP address of the Azure CLI into the firewall here. Okay, this is updated. Now if I go back, getting an error message. The reason is for the Azure CLI, we actually allow it from the Azure network backend. So if I add it to the firewall, it doesn't help because CLI is running from within Azure and not connecting from outside. So in this case, I have to say allow public access from any Azure service. This will let the Azure CLI to connect. So I'm going to remove it from here and just check this and save again. Now, if I go back, I should be able to connect from Azure CLI. Yep, I'm able to connect instantly. So it's as simple as that. So by default, we block all access, and this is for the security. And you can allow which client you want to connect to the database. And this is for the public access. Since it is exposed to the internet, it's important to protect it. Now let's look at the server that is deployed in the VNet, which is my PrivNet server. Here I'll show you the networking. It'll show private access, and it's connected to the virtual network MyAppNet as I showed earlier. And it's in this subnet MySQL. And there's a private DNS zone for this. Now from the VM1, which is in the same VNet, should be able to connect to this without any issues. And it would be also using the DNS to resolve the name that I'm not going to show here. Connecting from the other VNet, the VNet2, let us take a look at that now. Okay, I have a putty session to the VM2, and I'm going to connect to the database here. Yeah, obviously it's not going to connect. It doesn't even know what to do with that name. It's not able to resolve to the IP address to even attempt to connect. So we'll take a step-by-step approach here. Here we are not even able to resolve the name, right? So whenever there is a name resolution issue, the best tool is NSLOOKUP. And as you can see, we are not able to find the address of this server. So how do we fix this? So let's fix this first, then we'll look at the connectivity. Now here in the overview page, I can see this is the VNet it is connected to, and this is my DNS zone. If I go to the DNS zone and look at the virtual network links, I can see the current VNet we have deployed the server in. My AppNet is already connected, and there are some other VNets are connected to this DNS zone. So any resources within these VNets can resolve the database server name. But our VM is in VNet 2, my app VNet 2. So it's won't be able to resolve until we add that here. And I'm going to select the VNet 2 and click OK. The VNet link is created. Now let's go back and check if we are able to resolve the name. So I'm going to run the NSLOOKUP again. So now I'm able to resolve the name to the IP address. So this is the private IP of this database server. Since we are able to resolve the name, let's try to connect. Let's see what happens. Okay, we are getting the error message. As you might have noticed, most of the time the error message is same, but the reason for the error could be different. That's why it makes a big difference knowing the network architecture and how the connectivity flows to be able to troubleshoot here. So the reason for this is VNet 1 and VNet 2 doesn't have any connectivity between each other. Now how we will establish that is by using the VNet peering. Let us go to the VNet 1 here, and in the settings blade, go to peering and click add, and we give it a name. So I'm going to name it VNet 1 to 2, and this would be the reverse peering link. So I'll call this VNet 2 to 1, leave it default, and I can pick the VNet 2 here, and I'm going to allow everything and click add. So this is going to create two peerings from 1 to 2 and 2 to 1, and it's successful here. Now we'll go back. So as you can see now, the VNet 1 and VNet 2 has a peering here, allowing the communication between the two. Now let's go back to our VM and try to connect. Yep, we are able to successfully connect now. So the two things we did, one is link the VNet to the private DNS zone of the database server, and created VNet peering between VNet 1 and VNet 2. So that's it for this demo today. I hope this was a useful demo, and thanks for your time. And here I would like to share some of the resources on our Azure Database for MySQL resources page, where you have content of learning and some of the reference documentation and videos. For queries and feedback and a general roadmap of our product, please feel free to reach our email address, and stay tuned for updates. You can follow our social media pages for updates, features, improvements, and more learning content. Thank you for your time today, and hope you have a great rest of the day ahead.